so much for the introduction, and thank you for inviting me. It's a great pleasure to be here. And I hope you can hear me okay in the back. I'm fighting off a cold, and so my voice isn't so great. But I'll keep this very informal. I thought I would tell you a bit about the ReWalk exoskeleton, which I've had a chance to work with now for about 1.5 years or so. And so we have some experience that we could share with you and maybe compare with Amanda here who has the EXSO. So these are just examples of some of the powered exoskeletons that are in either approved or to be approved in North America. So there are 4 of them. The ReWalk is the one I'll talk about. That's the one I have. And the EXO is the one that's here at ICORD. And then here, this is just what they've been approved for rehab training or for home use. And the Indigo is a very interesting new one just coming up and expected to be approved very shortly. And then there's another one that's around and expected a little bit later. So those are the ones that are out there that I know of, which are about to be approved. And so just to tell you very briefly of what we do in our study, we have to screen people. So that's what this is about here. So we screen people, and I'll tell you a bit about that and the types of things we're screening for. And then once we deem them suitable to try the device, if they haven't stood for a while, then we have to stand them to make sure that they can tolerate the standing position. And you have to be able to stand for about ½ an hour at a time and not get dizzy, that kind of thing. And then we do a 12-week training program, which is quite intensive. It's 5 times a week, about 1.5 hours a day, and we take measurements before they start, and then during and after, and even 2 months after they've completed the training. The questions we're kind of interested in right now are, who is suitable? What type of person is suitable? We know a little bit, but really I think it's not very well known. What is possible in this device? So can you walk in the home? Can you actually do things in the home? What things can you do and not do? And can you walk with it in the community? And what are the problems? And this sort of thing. So this is the type of study we're doing. And finally, because you're training for 12 weeks, that's a fairly long time and quite intensive, we want to know whether it's changing your nervous system. And if so, what is changing? So those are the kinds of questions I'm interested in. So tell you a little bit about the screening part. And really, this is quite critical in the sense that not everybody can use the device. So the things we check for, the main things, are you have to have arm strength, enough to use crutches. And you have to have enough trunk strength that you can do a transfer independently. That's one of the gauges we use. The bones have to be reasonable. And I'm sure you know that with spinal injury, your bones weaken quite a lot. And so we have a cutoff that we allow. We do allow osteoporosis, but not hugely so. So for those of you who know, we use a T-score of -3. You can't have had fractures. And then, of course, you have to fit the device physically. So the weight, the height, the leg length, all those things have to be okay. I barely fit, by the way, into the device. So I'm a little bit too short, but I can walk in it. And then, of course, there are lots of medical things that we have to screen up for. So that's what we do, screening. To tell you a little bit about the device. So the picture here is showing an older version of the device. So if you look on the website now, it's slightly different. But this is the one we have. It has motors at the hip and the knee that moves the joints in the walking motion. And there's a computer and batteries that you have to carry around in a backpack. And that's about 5 pounds, the backpack. Now they've changed the design a bit now, and I think have made it a little smaller and modular, and it's actually on a fanny pack kind of thing. You have to wear a wristwatch-like device here, which I don't know if you can see very well, but that's where you select the mode. So if you want to stand, you want to sit, you want to walk, you want to go upstairs, downstairs, that's where you select the mode. And then the flip plates fit inside the shoe, and they have modified this a little so the device, the newer version is a little bit nicer. Oh, and one thing, there's a tilt sensor that is on the pelvic area, and it senses your tilt. So when you walk, and I'll show you a video in a minute, to tell the device that you want to take the next step, you tilt a little bit forward. That's the signal that you get. So here's one of our participants, our first actually. Let's see if I can roll over this thing. And this was early in training. So the one thing I want to emphasize is that it actually takes quite a long time for people to learn to use this device. It is not that intuitive. Even when we go in the device, it takes us a little while to actually make it work. Okay. But this is after this person had trained for quite a few sessions and could make continuous steps. So this is his early-ish training. So it's fairly slow. You see the therapist behind is actually hanging on and helping with the weight shift. And then this is him a little bit, 6 weeks or so later, he can really link the steps faster, and he got a lot better than this as well. But this just gives you an idea. Just to give you some sense, I didn't want to show a lot of data, but I just want to give you a sense of how far these people can walk. So they train for 12 weeks. At the end of 12 weeks, these are the 4 that completed more than 50 sessions of training. They can walk about a kilometer roughly without resting. And it's not exhausting after walking that. So that gives you a sense of how far you can go with the device. It's not super fast, but it can walk at about a little bit less than half the speed that a healthy individual would walk at. I mean, an uninjured person would walk at. So it's not super fast, but it's reasonable. And here's an example. Let me just find a mouse here. So here's an individual who learned to use this device quite well. She's walking outside, and all 5 of our participants so far have been able to walk outside without too much trouble, to my surprise, actually, even though the sidewalk is uneven. And you'll see that she can walk on grass, and most of them can do that too. It's a little bit harder on grass. And then you will see her trying to do stairs. So this is more tedious now. So each step you have to push the button, and you can see that she actually has to make all kinds of her own adjustments to make sure that the foot clears the step. And you'll see her try to do another one. And the therapist is actually wearing the watch because that's not so easy to do, to be able to do dual task, pushing the buttons and making sure you don't fall. And then you'll see her coming down, and she adjusts the strap because you need to lean forwards a bit. And again, as she comes down, you push the button for every step, and it's a little bit precarious, and you'll see if you look carefully at how the foot lands, and she controls where it lands. The machine just goes. And so it takes quite a bit of learning and finesse, and it's not super easy on those stairs. And then, of course, you would want to be able to walk up curbs, and so here she's trying to go upstairs a curb, and you can see her toe catches. So it was important to have the therapist there. And then she tries again. And this time it doesn't catch, but she can't quite pull herself up onto the curb. So there are lots of little issues, and it's not easy for these kinds of higher level walking skills. So just to tell you a little bit about what we found, adverse events of course happen when you use these devices. And I looked at, these are our participants, our experience, so we've trained 5, our 6th person just started. And on the right here is what I found from the literature. So there are quite a lot of groups working on different devices, and each of these numbers, the denominator represents the number of groups that have published results on these devices. So I'm just comparing ReWalk and EXSO. Skin abrasions, very common in the ReWalk. we had 2 participants who had to stop training for a period of time just to let their skin heal. And it comes from the straps typically, or the pelvic band that sits right on your sacrum area. So there's a problem. 3 out of 3 groups have reported this problem with the ReWalk. None have been reported in the EXSO, interestingly. And I don't know, I'm really interested in knowing some of your experience here too. But it may be the fit of the device. So falls, there have been no falls recorded in the literature. But we have had 2 falls with our participants. Now, they didn't hurt themselves because the therapist was hanging on, but she could not reverse the fall. And so she lowered them, but they didn't hurt themselves, but still, falls happen. And I think that's something that they still have to deal with as to how you make someone fall safely. So anyway, so I think it's still a big issue. Breakage of the device, we have no mention in the publications of any breakages, but we have had 2 breakages. And it was actually a physical breakage of the beam on one of the legs. And again, the person didn't fall because we caught it, but those are some of the issues that we think still have to be fixed. And then there is 1 report of a hairline fracture in the ankle of 1 person. A British group mentioned it. We have not had that problem. Now, whether or not they screen for bone density, I'm not sure. Some of the things that actually people have told us that it helps with this kind of walking. So bowel routine, 3 out of 5 people mentioned it, that it made their bowel routine faster, that they didn't have to use as many drugs, and that it was more frequent. And there's now an abstract published also on detailing this kind of thing. So I think this is very likely quite important. And in fact, these 3 individuals told us they would continue using this device just for this reason. So we allow people to come and use the device after they finish training, just on a sort of individual basis. And they are, 2 of them right now are continuing. Just less frequently, obviously, we don't have the manpower, but they are able to use it. Spasticity is kind of spotty. Some people say it improves, some people say don't say anything. I think and some people don't have any improvement. So I think it's very individualistic. Pain reduction. There is some reduction in pain in people who have really bad pain. So obviously, people who don't have much pain, and there are those too, nothing much changes. But those who have pain, quite a few of them had mentioned the improvement in a session. So after walking, they feel less pain. Whether there's a long-term benefit, we still don't know. And then psychological benefits, we are doing detailed interviews with people, and that data still hasn't been fully analyzed, so I can't tell you. But there has been 1 report in the literature that has mentioned these kinds of benefits. So just to tell you a little bit about what this is supposed to be, a device you can use at home, right? And the requirement right now is that in order to use the device at home, you must have a companion with you at all times, which is a bit of a problem, and all 5 of our participants said that was not possible for them. So I think that remains an issue. But we do test all these things. So because I'm in a rehab department, we have access to occupational therapy and kitchens and things like this. So we test the device in that situation once the people are quite good at it. And this is just showing you 1 video that shows some of the advantages that they like about the device in the home. So cooking, both the two women participants actually loved it in the kitchen because you can cook standing up, you don't burn your arms when you're trying to cook in a wheelchair, and you can do dishes, you can reach top shelves, that sort of thing was quite good. And you can see she doesn't really have to lean on the cupboards too much. She's quite balanced in the device. And you'll see her going over to a sink to do dishes, and she tells us that she really loved this because washing dishes in a wheelchair is like having water dripping all the way down your arms and that sort of thing. So those kinds of things it seems to be good for. But there are a lot of challenges still, I think. So falls I mentioned, stair function, you saw the video, it's not so great. Putting it on and off because of the foot plate being inside the shoe is still not doable for most people. I think we had one person who really could do it on his own. The ReWalk device is too wide for a wheelchair. I'd like this, I think, will fit in a wheelchair, right? The Ekso fits in a wheelchair, I believe, but the ReWalk doesn't. That's a problem, I think. And the control functions being on the wrist, I think, is a problem. I mean, it's a fixable problem, and I hope that they are thinking of that. And then finally, getting up from wide chairs is a big problem. If in a sofa, you could not get up in this device. With a wide chair, where we should demonstrate here, you will see that she has a bit of trouble getting all the way up. So just tells you a little bit about where things are at. So I think right now, it's a good training device. It allows you to walk with a moderate effort. It's good exercise. It trains your balance. We had actually one person who was not a walker before the training, and after the training, she could walk on her own. With great difficulty, but she could walk. And she, right now, actually, after much training, after being out of the exoskeleton, she is now able to walk on her own. And then I mentioned some side benefits. And it's a little, it depends on the person, it seems, but there certainly are some things that are coming out of the literature and out of our study as well. And then finally, I showed you some advantages in the home, and also there's lots of design improvements that I think still need to be done. So I think in conclusion, I think these are early days for these types of devices, and I do think that they will stay, and I think that the improvements will come. So that's all I have.
Awesome. Thank you, Dr. Yang.
I'd like to welcome everyone to ICORD.
Don't be shy.
It's wonderful to have this opportunity to share our research with you. So I think, as like Jaynie was pointing out, using these robotics is really learning a new way to walk. Because they are a bit different, and there are a couple of tricks to learning how to use them. So we can think of our spinal cord as a highway that kind of transmits signals from our brain into our muscles. And so we can see the connection to the leg muscles are happening in our lower back lumbar region of the spine. So when we have a spinal cord injury, these signals are interrupted. And for people with a complete spinal cord injury, you're getting no messages pass through. However, for people with incomplete injuries, we can get some messages through to the leg muscles. So physical therapy after spinal cord injury, therapists are focusing on treating a wide range of issues. They're working on positioning to prevent pressure sores, maintaining a range of motion and proper alignment. They're also working on transfer techniques, and they also focus a lot on gait training. And initially this started with using parallel bars and different types of crutches and braces to engage in gait training. And then we have body weight support treadmill training techniques that were developed. And initially this started with 2 or 3 therapists hands-on, where we have one therapist supporting the patient at the hips and one on each leg to move through the walking cycle. And then we had other devices further developed, where in this situation we still have the overweight body weight support, but the person's able to walk over ground, and the therapist is still there to support them to help their legs move through the steps. And now we have these devices this one's called the Locomat, where we have an overhead body weight support system and a treadmill, and we have robotic legs attached to the participant to do the walking movements. And now we have similar devices, but for over ground. So there's many different gait training options out there. And as Jaynie was kind of pointing out, these new robotic tools are exciting, but they may not be the best therapy option for everyone, depending on the criteria that you need to meet. And so why does practicing walking work? So when we move through the stepping cycle, we get sensory information from our leg muscles and joints that are sent up to the spinal cord. And in turn, they can send signals back down to our muscles. And so when we practice walking, and we get many, many steps, so we're generating a cycle of sensory information that's being sent up to the spinal cord. And for people with an incomplete injury, some of those signals might get up to the brain and back. And that's how we're getting our improvement in walking function. So when we engage in gait training, there's not only improvement in walking function, but there are also many secondary benefits that have been reported in the literature. So we see that people can improve their balance after gait training. We also have increased muscle strength and size, reduced muscle spasticity, improved breathing and lung function, so better use of oxygen in the lungs, but also improved timing of our breathing rhythm with our walking cycle. Better cardiac function after training, so there's an aerobic benefit, and improved bladder and bowel function. So upstairs on the third floor, we have Locomat, which is a robotic gait orthosis. So you can see in the picture here that there's robotic legs attached at the hip and the knee joint. And the legs are going to automatically move through the walking cycle. So some of the pros of training with the Locomat is that we have a body weight support system. So for individuals who can't support their full body weight, we can offload some of that weight and then put it back on when they get better. We also have automatic assistance to the leg movement, so they're automatically going to move through the walking cycle. And as the person gets better, we can reduce how much the robot is helping them, and they have to put in more effort to the movement. And finally, with the Locomat, we can generate many steps, since there's a fast maximum speed on the device. So the more steps we're generating, the more time that cycle of sensory information moving up to our spinal cord and back is happening. However, there are some limitations. So in the Locomat, we don't have these side-to-side movements at the hip that we have when we regularly walk, and there's no rotation at the hip joint. And secondly, each movement is very consistent and the same for each step cycle. And we know from research that the more variable our steps are, the better able our body is to learn. So that's one of the, training kind of barriers that we have to get through. So research studies on the Locomat to date, there's quite a few. Generally, they have shown that participants with incomplete spinal cord injury can walk better after. So this means faster walking over longer distances. And they've also found improved muscle strength. These protocols usually involve 3 to 5 sessions a week for up to 8 to 12 weeks to get these benefits. And from our randomized controlled trials in the literature, so those trials have the highest level of evidence. It's shown that the benefits that we get from Locomat training are no different from the benefits that we get from other types of training methods. So when they compared the Locomat to treadmill training with therapists and to overground walking with parallel bars, it was no difference between the different training groups. They all got the same benefit. So it really highlights that we maybe need more research developed onto optimizing our training programs with these robotic devices. All right, so we have an EXSO as well. It's brand new to us, about 2 years old now. And I'm gonna kind of go back to talking about weight shifting. And so when we walk, we shift our weight on each foot side to side. And you can kind of see this balance. You can see this balance point, and the person has to shift that balance point forward onto this foot for walking to happen. And the EXSO uses that same principle. So you take a step forward and you have to shift your body weight forward. And when you reach a certain point, there's targets set into the EXSO, it will know to generate the next step. And then you're required to shift your weight over to the next foot, and then the steps will keep generating after that. So some pros of using the EXSO. It's forcing you to engage in balance control mechanisms. So you have to learn how to shift your weight and balance over your foot and find the spot where you're balanced. There's automatic assistance to moving the legs, and similar to the Locomat, you can do full assistance or partial assistance as you get better. We can scale back how much it's helping you. And the EXSO, because it's over ground and you're using your dynamic movement, there's more variability in the steps, which is good for motor learning. Some of the cons of using these devices, as Jaynie was saying, there's a higher risk of falling. So you need to follow all the safety protocols and have a therapist with you when you're training. And she also kind of highlighted that the walking is fairly limited to level ground. They say it can do a 2% grade, which is very slight incline. And so because the EXSO is operated by your shifts in body weight, the speed is a lot slower compared to the treadmill devices. So you're not generating as many steps as you could probably get in the Locomat. Okay, so studies to date on the EXSO. There have been 3 case studies published. So this first study had 5 people in it, and they had the goal of just seeing how long it took people to use the EXSO. And so they found that most people were able to learn how to stand and walk in the EXSO within 20 sessions with minimal assistance. People were able to walk from 110 to 670 meters, so there's quite a range in abilities, and they rated their effort from light to hard when they were using the device. The second study had 3 people in it, 2 complete injuries, 1 incomplete. Again, they were looking at the feasibility for someone to use the EXSO, and they found that people can walk faster and walk over longer distances after 20 sessions. People reported to them at the end that they felt less fatigue and pain and reduced physical effort to use the device. So you can see there's we're at the beginning of research on these devices, and there's still lots of other things to look at in terms of outcomes. And so we're starting our EXSO training study, and we have currently 1 person enrolled. And so we're looking at the impact of gait training on balance control. And so we're going to have 2 groups of people. The first group is going to have EXSO training for 10 sessions, followed by Locomat training for 10 sessions, and then another bout of EXSO training for 10 sessions. And so each of these 10 sessions we want to be completed within 3 weeks. So we're looking at about 9 to 10 weeks of training in total. And group 2 is going to do the reverse order of the conditions. And at each of these black arrow points, we're going to measure your balance control. And so I have data from 1 person to show you, just on this first phase of EXSO training. So just to show you what our seated balance control test looks like. So we have a person sit on a forced platform, okay, and it measures all the forces underneath them. And their feet are dangling off the ground there, so they really have to use their trunk muscles to control their balance. And so for the first static test, we ask them to sit as still as they can with their eyes closed. And you can see this green point is just their center balance point. In the dynamic test, we have them sit still, and then the yellow arrow shows up, and they gotta lean as far as they can in that direction and come back into the red square. And so we do all 8 kind of cardinal directions around. And so we have 1 person in our study so far who's a complete injury at level T4. And so if we look at the first graph on the left, this is our static balance condition. And then we can see after training, the balance points got a lot smaller in terms of their movement, so they are better able to sit still after 10 training sessions. And if we look at our dynamic condition on the right side here, this is the before and this is the after, the participant was able to lean further in each direction and come back to the center. So they're getting more control of their movement and further in each direction. So continuing on with the study, we hope to show that EXSO training can improve seated balance control. And this is important for people who use wheelchairs as their primary mobility tool during the day. So if we can improve their seated balance control with some gait training in the EXSO, hopefully it will help their activities of daily living. And I'd just like to say thank you. All right, and we do have a demonstration for you. So I would like to introduce Kyle Jaynie, who is our expert EXSO user. He first started with us when we got the EXSO 2 years ago, and we were training with the company. He was our first participant up in it. And so he's going to show you kind of how it works, and if you have questions for him or during the question period, make sure to write them down. So one of the first things you have to learn is how to stand up. And so this is part of the movement where Kyle actually has to put in a lot of work. So the device itself is about 50 pounds and it can stand up on its own, but it can't lift your weight. So you actually have to put in the physical work to push your body up. And you got to do that either through the arm crutches or you can use a four-wheeled walker. You ready? 90. 1, 2, 3. Ellie, you want to start? So usually within our first session, we have to go over the whole sit to stand. And then we usually do quite a bit of time just in standing to learn kind of where your balance spot is in the device. And sometimes you may think you're balanced, but you're actually like leaning back. So we have to, correct you and get you into the right spot. Move the table over. So are we, I guess, turning this way? We'll go that way. We'll go that way. Okay. And so Kyle has to shift all his balance onto the left foot, and then a right step will initiate. I'm going to give him that. Ready? And then now he's under control with his weight shifts.
Floor so slippery.
Oops. Okay. Let's start again. So the EXSO has a walk mode, and it also has a turn mode. So when you get to the point, it will give you kind of one step, and then that's how you turn yourself around to go in a different direction. Kyle's actually gotten a lot better at it. If he can go wide enough, he can pivot by himself. Come back.
Sorry, if I can turn, one step at a time.
I can give you, yeah, I can give you one step. It's a shift left, and then here we go. And then so turn mode, and then you would just kind of pivot your feet. And then I can go back to a walking mode. And then go back to your sit. Shift left. Yep.
So on our panel here, we're going to have Dr. Yang, Dr. Chisholm, and joining them is Dr. WOLFRAM TETZLAFF, who is a professor in the Department of Zoology and Surgery at UBC. He is also the director of ICORD, so I'm sure many of you have seen him around. His expertise are in preclinical research, and in particular on neural protection and stem cell transplantation for neural repair following spinal cord injury. And beside him is Dr. Jaynie BORISOFF, who is a research director at BCIT, as well as a principal investigator here at ICORD.
So we had a lady who was C6, or C7 I should say, I think, C7. And the lowest we had of those 5 was a T6. And so some of them were complete lesions, some of them were not. But the C-level ones were all incomplete.
Would there be a C in the qualification scale of Asia scale or so? What level would there? Would it be C or D?
So the C is with a little bit of motor remaining, right? And that particular, so we have 2 Cs, and I think both of them were about C7. One may have been classified as C6, but in any case, they had some triceps in their arms and they were incomplete.
Perfect. And does that answer the question?
Yes.
So I guess if I read out the question and somebody has a follow-up from that, just let us know and hopefully we can get some discussion going on that. I think that's okay. If you have a question pop up during the time, again, let us know and we'll get that question in. So the next question, I think it's open to the board. So T4 complete has no abs. So how are you improving seated balance?
There we go. I'll take that one. So even with complete injury, you can still have some sparing of spinal tracts to the abdominal muscles, even if they're not functional. Some research has shown that you can activate them. So if you're engaging in balance control, we're hoping that we can still train some of those muscles.
Do you need those muscles to work the EXSO?
No. Yeah, you do. Yeah, you don't need the muscles to work the EXSO. So like Jaynie was saying, you have to be C7 or C7 could be the highest you could be with a complete injury. You have to have some tricep function. So you could do the weight shifting using your arm muscles. Thank you.
So my injury is T4 complete. So yeah, I don't have like any abdominals or any core, you could say. But I have a lot of different functions. Like she was, Dr. Chisholm was putting some nodes on my abdominals, really down low kind of thing. And I was also doing a different study with Dr. Anna Bergfors from Sweden. She did a study here a couple of years ago, and we were trying to engage the stomach and engage the core kind of thing. And even though I was a T4 injury, I still had some sort of abdominal function and some sort of return going on. If I really tried and worked hard at it, you could see some sort of contraction in the muscles down below it. And even though they say that I'm not supposed to have any function below there, that study did show that I did have something going on there. So no matter what, no matter if they say you don't have any abdominals or don't have any control, personally I think that's a lie, because I'm Asia A, like complete injury, and I still have some balance, I still have some control. And like Dr. Chisholm showed on the balance test that I was doing, I did have some more balance and some more control in that sense. So.
She never said that was you.
I'm the only participant in this study. What's the deal?
Protect your identity. It's sorry, and both brought up a good point as well. It's a limitation of the classification system. So when we do an Asia test, we have good movements to test our arms muscles and our leg muscles, but we really don't have good tests for our ab muscles for classifying the levels.
Awesome. I think that answers the question. Sweet. All right, so I'm going to ask this question. This is a very common question I've seen a couple times. What is the price of a bionic suit?
Start with yours.
The EXSO is about 100 grand to 110.
Is that US or Canadian?
US, so right now with the exchange rate, not so hot.
And I think the ReWalk is somewhere in the 80,000 range US again. So depending on if it's a personal unit or a rehab unit, but somewhere there.
There was an announcement last month from a new company that from the inventor of the Ekso suit he's not involved with it anymore. He has a new company now, and they have one that will be priced at $40,000 US in a year or two once they get through their development work. So they're coming down slowly.
Getting affordable slowly over time. So maybe another question on this: how much time is needed to suit up in the EXO or the ReWalk?
I would say it's about like 5 to 10 minutes to get all the straps and everything on.
And I would say maybe 15-ish to get it all right.
Depends on, the amount of function the person has, and depends on the amount of function the person has. If they're good at transfers, or it takes them a while to transfer, if they can put their own backpack straps on and that kind of stuff, it makes it all faster.
And I think the companies kind of have different strategies for how to get in and out of. The companies have different strategies for how you get in and out of exoskeletons. I think the ReWalk is probably the worst in that regard, that they haven't done a lot, but they were one of the earlier companies. The EXO has hinges on it that the leg can actually swing away, so you can move your wheelchair up closer to it than transfer. The Indigo exoskeleton is modular, and you can actually kind of strap it onto you while you're sitting in a chair. If you think about kind of like Iron Man, how it kind of assembles around him, that was kind of their strategy. So they're kind of acknowledging that getting into and out of these things can be quite a challenge, so they're looking at different ways to facilitate that.
The next question we can ask here is, who can apply for screening? Yeah, we'll stick with that one. Who can apply for screening?
So I think I'll kind of take it from two sides. So some of you may know that GF Strong also has an EXO. And so if you're involved in one of their rehab programs, you can talk to your physiotherapist about EXO training and doing the screening with your physiotherapist. If you want to try EXO as a part of a research study here with us at ICORD, you can email Allie, wherever she is, at the back, And we can tell you about the study, and we can go through the screening together.
Perfect. Does that answer the question? Sweet. And are there any other devices in the work? I know we touched, Jaynie, you did touch base on that, but maybe we could touch base on that again, and maybe how they compare to the ReWalk and EXSO.
Well, actually, there are a lot of devices in the works, I think, but I have just been able to follow closely the ones that actually have some publications on them, but I know that there are others. So what was the question? How do they compare, or what?
Yeah, like maybe how do they compare with the ReWalk and the EXSO comparatively, if you know?
So the only one I know a little bit about is the Indigo, and it's still not approved right now, but and as already mentioned, it's a modular system. It looks quite different, I think. The walking looks very good, and it doesn't have any push buttons that you have to, control like the EXO and the ReWalk. Somebody has to be pushing the buttons to tell it what to do. This one is entirely supposed to be intuitive, so it figures out what the person is trying to do based on a whole bunch of sensors that they have in the system. So it looks very promising, but of course, no one's had to lay their hands on. Well, the U.S. there are a few centers that are testing it, but I haven't had a chance to work with it, so I really don't know.
I can say. And then the other one I mentioned, that the $40,000 version is called Suit X. Again, there's very little known about it right now. It's going to be cheaper. It's also going to be lighter. It doesn't have knee motors actually, so it's actually using a different strategy. So it's trying to reduce some of the mechanical complexity of it and make it a little sleeker. So that means it won't probably have as natural gait. It would be more designed for just walking as opposed to, say, neural retraining of motor function and gait function. And then the other one that was on Jaynie's slide, it was the Rex exoskeleton that you may have seen pictures of. It's the really big one. It has very large sides to it, and it's the only one that can actually self-balance. So you actually can just stand there and drive it like a power chair with a little joystick. So you can walk around very slowly in it, and it's using its mass and footprint to balance. So it's again designed for as more of an assistive technology or a mobility device, albeit a very, very slow one, as opposed to one of these devices that are designed for walking training.
I believe there was also one with inbuilt muscular stimulation, electric stimulation of the muscles.
That would be, well, the FES actually, that has, the Indigo does that, the FES, but also there's one out of Japan, HAL, exoskeleton as well, that uses EMG recordings actually, and uses residual muscle function to actually control the device as well. So that's yet a sixth one, I guess, that is out of Japan. I believe it's available in Europe. All of these, not all of these, but three of them at least are available in Europe right now, actually, and so I think there might be a slightly easier regulatory path through the EU than there is in North America.
Fewer lawyers, less litigation.
Yeah.
I'm just wondering, can any of those other than the ReWalk, go upstairs or curbs? You know?
The EXO can't go upstairs or curves, no.
The
I'm not
Rex,
sure.
the big Rex can.
Mm-hmm.
I believe the Indigo is supposed to be able to, but again, there's no data on it.
Have you seen the Rex go upstairs?
No.
Yeah.
Me neither.
But it does say that it can,
Yeah,
yeah,
yeah.
correct.
I've seen the video. It's very slow.
Awesome. Next question, do physical therapists need training to use the device? And if so, what type of training?
So each company has their own system. Yes, you need training. In the ReWalk system, they don't require that it be a physical therapist. They just call them trainers. But I do think that having a physical therapist there is useful because of all the other things that go with spinal cord injury. The training is not very intensive. It takes about 2 days or 3 days. It's not that long. So we trained within half a week or so. I think EXO is a lot more
Yeah. Extensive.
Yeah, so for the EXO training, we did 4 full days of training with their physiotherapists that come up from the company. And then we practiced with the device for the next 6 months, and then they came back for phase 2 of training, and we did 3 more full days with them. And so and in between that time, we also actually had them come back a 3rd time because they updated their software and added in a new feature, so we were kind of updated on their new technologies.
Do you have to be a physiotherapist to use the EXO?
So for EXO, yes, they say you have to be a physiotherapist to be certified with them. That being said, I'm not a physiotherapist, but I have undergone the training. So I'm able to use it here as a research center. Wouldn't be able to use it in a clinical practice scenario.
Research only.
Yeah, research only.
I have my training at use it at GF Strong, and you can train after your level 2. You can have other people that are not physios work with you and direct them to do it. So it doesn't have to always be.
Awesome. Next question. Do you foresee a point when this technology works in conjunction with orthotics to enhance fit construction and streamline design? And I think when I was talking to the gentleman, he was saying that he was wondering whether, if these exosuits are going to work with technologies like orthotics to improve fit design.
I'm not sure about that, but the ankle joint is like a spring-loaded joint, so it does give you some motion depending on the type of orthotic that you have. You can get some movement at the ankle joint.
So I believe the Indigo has an ankle orthosis, and the ReWalk does too now, I believe. More of an orthosis.
It's a foot plate.
It's a foot, okay.
Yeah.
And I also know the ReWalk institutional model that you have is fully adjustable through a lot of sizes, but the personal model is customized to the individual. So that's starting to get at that kind of personal orthosis, that it's designed from the factory for the person, and hopefully that'll help some of these skin issues maybe that you're seeing and others are seeing. So I suspect they will start moving that way though, more as they get into individual use models as opposed to ones that are for a research center that you can set up for many different size people.
And I think I see where you're coming from, that maybe some custom fitting would help the fit of the device on the person and slide less, and I'm sure that that's true. I don't know how much of that they are right now planning to do, but I do think that if they had combined with orthotics a little bit more and used the know-how of fit in just orthoses, which have been around for a very long time, it probably could have been better right from the get-go.
That's the question. Awesome. Next question is an exercise question. So, what would be better for exercise, the park gym or swimming?
Really?
Always a question.
Yeah, Ali and Megan would say always in park. I guess it depends on what your exercise goals are. Swimming has a lot of benefit because it's non-weight bearing.
Both.
Yeah, and there's aerobic benefit, and then park has similar machines. Megan, I don't know.
No, I was just saying, why not do both?
Yeah.
It's good to alternate. It's good to work your muscles in different ways. So come to the gym 3 days a week and swim twice a week. Perfect.
Oh, wait for me. All right. I forgot. So I just got another question here. So one is, how soon after post-injury can you start training? And also the level of injury. So what's the requirement for the level of injury?
So for us, for research, we usually look at individuals who are at least 9 months post-injury. And the level, I think it's similar to before. So you have to be, C7 or lower, and have some hand strength and arm function to push yourself up into standing and transfer.
And so we have the same requirement that you be long after injury, at least 1 year, but I know that the study is starting in Calgary that is going to be for subacute people, so people who are still in the hospital. This is Dr. Chester Ho's work. So they have an EXSO now, and they're going to try to get people up very soon after injury.
It strikes me that when you go through the animal literature and see how many repetitions you need to get good rehab effects, that we're not nearly there with these type of devices, that we just cannot get up to the numbers of steps that we would really acquire to actually get close to the benefits we see in animals. What are your thoughts about that from your end?
Yeah, so in our walking studies, we work towards people getting somewhere in the region of 2,500 steps per session. So I think that is getting close, but that's at the best. So they're working up from very low numbers up.
Another question was, how often do we need to do hardware or software updates on these types of machines?
For the EXSO, right now, whenever they have something new come up, we get the update. So they send up a technician, and if it's like hardware parts they're replaced, or if it's a software update, they actually can do that remotely.
So we have had a lot of repairs done, and they have to fly in every time to do it. So we've had extremely good service from the company. Absolutely no complaints. But buying the warranty was absolutely worth it. So there are a lot of, let's say, lots of repairs and fixes. They do have a standard maintenance of every 4 months.
It's called Apple Care.
I had a question, Dr. Yang, about you said with the ReWalk they use a communicator. I know with the EXSO you can eventually get to a point where the person can initiate their own steps by targeting. Do they have that same type of feature with the ReWalk, and can you eventually become independent with the ReWalk?
Okay, so there are a lot of questions embedded in there.
Yeah.
So first of all, the triggering of the steps is the person leaning.
Oh, okay.
Okay, so the push button is like whether you want to walk, or whether you want to go upstairs, or whether you want to sit down, that kind of thing.
Oh, I see. Okay.
Yeah. And so what was your other?
I think this is just a general question that other people had was, I think it's the $1 million question, is how far is this technology from being able to use independently at home?
Well, I think it's a little ways yet. Like really, I don't think that they say you have to have a companion, and I really do think that that's essential. You can't, it's not safe to not have somebody else with you, because if you fell, you wouldn't be able to do anything, and there are all kinds of issues. So right now, I don't think you can be independent in it. But I was talking to somebody at the break who was working on this exact problem of what do you do in the case of a fall in an exoskeleton. So in the engineering side of it, if you could figure those things out, then maybe it will be possible, and I think it probably will be eventually.
Maybe a follow-up question on that?
Yeah, sorry.
Yeah.
So what I've noticed in looking at the robotics technology is that some of the walking robotics that are out there today are much more advanced than any of the exoskeleton suits. Like a couple weeks back, one of the DARPA programs, I think it was called Atlas by Boston Dynamics, that was the video, I don't know if you guys saw on the news, where you took a stick, hit it in the chest, and the thing did a 5-6 step stutter step backwards and didn't lose its balance. So what do you think is holding back exoskeletons from robotics?
So, no, that's a good question, and it's something that we get asked that a lot, especially as rehab engineers that are interested in these sorts of things. So those robots are designed with really light legs that can move really fast, and obviously a very light body. So now imagine this device moving a 200-pound person. So that's in a nutshell the difference. That is moving a 200-pound passive sometimes even actively fighting you system versus something that's designed from the ground up to be very light with these very light legs that can move really fast to take these steps. And I'm working with the grad student that Jaynie was talking about that's working on how exoskeletons fall or not necessarily how they fall, is that they just fall right now. No company to my knowledge is working on falling safely in an exoskeleton other than using the therapist. So that's a major problem that they have to figure out, and there's no easy answer to it because motors, actuators, batteries, and mass does not scale at Moore's law like computers do, and it's a difficult problem that's going to probably take a while to solve. Or there's the Rex version, right, that it's using a massive structure to move a heavy person, and the whole system is designed to be balanced all the time, and so that's how they get around it. So your trade-off there is big, bulky, and slow. So right now we don't have any answers to that, unless you want to combine it with a Segway or something and use wheels, which actually is not that crazy of an idea, and that certainly you can balance things with wheels quite well.
Like the hoverboards these days.
And did we have any more questions? I think we're okay. So, I'd like to finish off by, again, thanking the Rick Hansen Foundation for supporting the event, SCI BC and Jocelyn for being here and recording everything for us. Of course, I'd like to thank the panel again. And again, I'd like to thank all of you for coming. This was really cool for me because I've been at so many events here and we're always talking about the research perspective and the research perspective, do you know what I mean? And this is really a perspective from people who are dealing with spinal cord injury and those types of questions, which are so different from the research people. So it really was a great perspective. Thank you all for coming, and we'll hopefully see you again at these types of events. Thank you.